Good morning, chemists, and welcome to another lesson all about acids and bases. And today we're going to be focusing on one of my favorite lessons from this unit, which is all about acid-base indicators. And I don't know if you guys have picked up on this, but I really love and appreciate colorful things, as evidenced usually by my notes. And so that's why I think I love the idea of acid-base indicators so much. So let's go ahead and jump right in. So what exactly is a pH indicator? You guys may have used pH indicators at home. I know growing up, my parents had a swimming pool in the backyard, so we did use indicators to test the pH levels of the pool. And what an acid-base indicator is going to be a compound, okay, which changes color based on the presence of H plus or OH minus. And this is a really oversimplified understanding of an acid-base indicator. It actually does become much more complex than this, but for the purpose of this course, all we really need to know is that it's a really cool substance that's going to change color based on the relative pH of your solution. And they're often used to test for a specific range. Okay, so certain indicators work better for testing, let's say, a pH range of like 3 to 5. Some might work better for testing pHs of like 9 to 10. And we'll talk all about that in just one moment when we look at the acid-base indicator table. So in your reference tables on that page, I forgot to photocopy, I do apologize. There is a reference table, table M, which is our common acid-base indicators. And so for this course, we're going to talk about methyl orange, Bromthymol Blue, Phenolphthalein, litmus paper, Brom Cressel green, and Thymol Blue. And there are more indicators than this. This is just a selection of acid-base indicators, but they have the indicator name, the approximate pH range, and the color change that we expect to see. So I wanted to take a minute to talk about how to read this table, and in doing so, we're going to be using these colors. Okay, we're going to use the colors here. So for our first indicator, we have methyl orange is the name of our indicator. And note that it has the approximate pH range for color change 3.2 to 4.4. It also tells you that the color changes from red to yellow. So how are we going to read this? Well, the number that's correlated, or the color that's written first, is in correlation with the number that's written first. And so what this is telling us is that methyl orange will be red in any pH that's 3.2 or lower, okay? So 3.2 or lower, so I'm going to go ahead and use this right here. This would be a red, that would be a red color, okay? That would be a red color. When we see our second color here, okay, it's actually going to be yellow, and it'll turn yellow in pHs of 4.4 or higher. So that means here that I have, okay, 4.4 or higher. It's going to be a pH, it would turn yellow in those solutions, okay? And so when I said previously that it's used to be test for specific ranges, let me be really clear here. Let's say I was testing 2 or 3 different solutions that are all bases, okay? And I was using methyl orange. This would be a really impractical use of methyl orange because every single one of those bases are going to turn yellow. If we wanted to really make use of methyl orange, we would want to test somewhere in that range of, maybe 3 to 5 in that range. I'm trying to figure out more about this solution, about whether or not it falls within like the 3s, the 4s, or the 5s, okay? That way we can see if it's red or yellow. All right, Bromthymol Blue is yellow in pHs of 6 and under. So we're going to go ahead and just say this, right? 6 and under, it would be yellow. And from 7.6 to and higher, it's going to be blue. 7.6 and higher, it's going to be blue. So we're going to go ahead and note that here. Okay, The next is phenolphthalein, and phenolphthalein is a really common indicator. We use it most frequently in this class, more than any of these others, because most frequently when we're using an indicator, at least in Regents level chemistry, what we're doing is we're looking at a titration, which we'll learn about next week. But phenolphthalein is really cool. It goes from colorless to pink. And so it's going to be this like kind of fuchsia-y color at a pH of 10 and colorless before that. Okay. Litmus, I'm not going to color anything for because we talked about litmus previously, and I'm going to put that maybe up here, and we'll make note that for litmus, remember we said that acids, okay, are going to turn blue litmus paper red, and bases are going to turn red litmus blue. Okay. Next, we have Brom Cressel green. Brom Cressel green is going to have a yellow, a yellow to blue change. So 3.8 and lower, it's going to be yellow. And for blue, it's going to be blue above 5.4. Okay, so 5.4 and higher, it's going to be blue. And then for Thymol blue, I'll do the blue first since I have that open, 9.6 or higher, it's going to be blue. Okay, so 9.6 or higher, we have a blue color. And then we have for lower than that, for the yellow, okay, 8.0 and lower is yellow. All right, so now that we can see what table M is and kind of how to read it, let's do some practice using that. Okay, so here we have our first solution. Okay, our first problem, you received 2 solutions and a bottle of methyl orange. Okay, so we're talking about methyl orange, that top indicator. When methyl orange is added to each of the 2 solutions, they exhibit 2 different color changes. Solution 1 exhibits a red color and solution 2 exhibits a yellow color. What information can we conclude about the relative pHs of the solutions? Now, we can't really conclude too much, but we do know that if solution 1, and let me go back and just kind of highlight this, solution 1 exhibits a red color. So going up to methyl orange, what does that mean if I have red? I know that my pH is going to be 3.2 or lower. Okay, 3.2 or lower. So for solution 1, my pH, okay, is going to be less than or equal to 3.2. Okay, that's all the information that I conclude about that. I can't conclude any other information. For solution 2, it exhibits a yellow color. Okay, so what can I determine about solution 2 then? Okay, for solution 2, our pH, okay, has to be greater than or equal to 4.4. Okay, and that's really all that we can conclude about our 2 solutions. We know that the one falls somewhere below 3.2 and the other falls somewhere above 4.4. Now, let's suppose I had a solution that had a pH of 4 and I wanted to test it using methyl orange, or I used methyl orange to test it, but the pH was just 4 on the dot. What color do you think that resulting solution would be? So our indicator for less than 3.2 is red, for greater than 4.4 is yellow. And so if I were to test something that falls in the middle of that range, it's going to be a mix of the 2 colors, or it's going to be orange. Okay, so we would end up with an orange solution because the pH of 4, okay, is between 3.2 and 4.4, and red plus yellow equals orange. So going back up to our table up here, these colors can be, right, kind of mixed to determine what would happen in that pH range between them. So for methyl orange, it would be orange between. For the Bromthymol Blue, we would get a green in between. Phenolphthalein is interesting because it goes from colorless, and so I wish I could do it justice to kind of shade it on this, but what ends up happening is we end up with a very, very faint light pink starting at about 8 and then ranging all the way up to 10, getting really, really dark. So I'm just going to kind of highlight, but that's not even doing it justice. And I'll show you guys proper phenolphthalein scale at some point in this unit. All right, Cressel green is going to be green between, and Thymol blue will also be green between. All right, excellent. Now, let's take a look at 3 more solutions. So given the pH, we want to give the pH and predict the following colors. So I gave concentrations, determine the pH, and give the following colors. So let's first start with 0.1 molar NaOH and phenolphthalein, okay? So 0.1 molar NaOH, we are talking about OH minus. So our concentration of OH minus is 1.0 times 10 to the negative 1, which means that our POH is 1, okay? That means that our pH is 13. And so what color would phenolphthalein be in a pH of 13? Well, let's scroll back up. In a pH of 13, it's going to be a pink color. Okay? Second solution, maybe pause and try this on your own and then check your answer. Okay, in our second solution, we have 0.1 molar NaOH. Okay, again, our concentration of OH minus, since we're talking about NaOH, is 1.0 times 10 to the negative 2. Our POH is 2, and therefore our pH is 12. So what color would Bromthymol Blue be in a pH of 12? Bromthymol Blue turns blue starting at a pH of 7.6, so at a pH of 12, it would be blue. Okay, and then for 0.001 molar HCl, okay, here we're actually talking about HCl. So our concentration of H plus is equal to 1.0 times 10 to the negative 3. Therefore, our pH is 3. And in Thymol blue, what color is a pH of 3? It does not, pH of 3 falls before the indicator color change, so it would be yellow. All right. Now, using table M, answer these questions using the following scenario. So we have 4 colorless solutions, and they're tested with indicators. Using the results of the test, which solution is most acidic? Solution 1. Solution 1 is tested, and Bromthymol Blue is blue. So what does that mean about the pH? Okay, Bromthymol Blue is blue. That means our pH is greater than 7.6. Okay, so pH is greater than 7.6. Okay, and in solution 2, okay, solution 2 is tested and Cressel green is blue. Okay, so Cressel green is blue. That means our pH is greater than 5.4. Okay, let's see. Solution 3 is tested and phenolphthalein is pink. So phenolphthalein is pink above a 10. So we are going to say that for solution 3, pH is greater than 10. And for solution 4, solution which methyl orange is red. Methyl orange is red when the pH is less than 3.2. So pH is less than 3.2. So of these 4, which solution is most acidic? Well, remember, the more H plus there is, the more acidic it is. So the lower the pH, the more acidic. So solution 4 is most acidic, okay? And we can explain that very simply by just saying that the pH of solution 4 is lowest of all solutions. Okay? All right, just a couple more questions and then we will be set with indicators. So again, let's go ahead and just take a look here and talking about pHs. So Using table M, answer these questions. A colorless solution was tested against Thymol Blue and found to be yellow. What does that mean about the pH? So a colorless solution was tested against Thymol Blue, okay, Thymol Blue, and found to be yellow. So that tells us that the pH should be less than 8, okay? That tells us that the pH should be less than 8, okay? Less than or equal to 8, okay? The same solution was tested this time using Bromthymol Blue, and it was found to be blue, okay? So Bromthymol Blue, and it's found to be blue, means that the pH is greater than or equal to 7.6, okay? So pH is greater than or equal to 7.6. So based on this, we've now used 2 indicators on the same solution. What information can we deduct about the pH? Well, looking at these values, this actually tells us a lot of information. We now know that there's a very small range in which our pH can exist. So our pH, according to this solution now, can only fall between 7.6 and 8. So the pH falls between 7.6 and 8. Okay? I'm going to pause here in the interest of time. We'll take a look at this next question in class tomorrow. Have a great rest of your day, everybody, and I will see you then.